Hello and welcome to this IB Maths Intense session looking at the binomial theorem. This is just a gentle introduction to the binomial theorem and is the first in a number of videos that will develop the binomial theorem and the binomial expansion. You'll see from the syllabus links in the bottom right hand corner, this is a standard level topic, SL 1.9, and then there are some extended components for higher level 1.10, and we will look at those later. In the context of what we've been doing, prior knowledge, work on factorial notation, work on combinations and Pascal's triangle, some of the work on geometric sequences, all feed into what we will be using for the binomial expansion. So do take a look at the videos on those topics in advance if you haven't looked at those areas already. And sure enough, there is the binomial theorem as it is listed in the syllabus document. You'll see there's the standard level component, simple binomial theorem expansion there, SL 1.9, and for the higher level students, there's the extension of the binomial theorem that we'll be dealing with later. So, just for this session, just an introduction to what the binomial theorem is about. Well, binomial expansion, binomial as the word kind of indicates, is all about two numbers or two terms which we are going to expand. So it can be denoted algebraically as any expression that takes the form a plus b to the power of something. A and b can be anything really, and then n can be a power, and ultimately we'll be able to have any sort of power for the binomial expansion. But for the purposes of just showing how this works at the simplest level, let's look at a number of different ways in which when we expand out a plus b, we get our result. So a plus b to the 0, we know that anything to the power of 0 is going to give us 1. That's a rule we should all know. So a plus b to the power of 0 gives a result of 1, which I've written there. A plus b to the power of 1, anything to the power of 1, is itself. So we'd just have a plus b underneath there. But just to make the point, I've written that down in the table as 1a plus 1b. And I'm hoping that already, even after 2 rows, you're starting to see the pattern emerge with those numbers. And sure enough, if we look at the quadratic a plus b squared, we would end up with a squared plus 2ab plus b squared. And again, if I write that down in the same way, you'll see it as 1a squared, 2ab and 1b squared. I hope that you can see already what's emerging there from the earlier video that talked about Pascal's triangle. We're starting to develop Pascal's triangle as being the coefficient in front of each of the terms. A plus b to the power of 3, you can guess, I guess, from looking at the pattern in the numbers, what those coefficients are going to be. And sure enough, we get 1a cubed. The first item in each row is 1. And then the sum of the two numbers above gives us 3a squared b and 3ab squared and 1b cubed. And hopefully you start to see the pattern in those numbers. Because if you remember 1, 3, 3 and 1, these were the terms that were given by our combinations notation. So the one at the beginning was our 3c0. How many ways can I pick? Nothing from 3, and then 3c1, 3c2 and 3c3. And notice the symmetry there. The number of ways of choosing 1 was the same as the number of ways of choosing 2 from 3. So 1, 3, 3, 1. Every row is symmetrical. And you can probably guess what the expansion of a plus b to the power of 4 is going to look like using the same pattern. And sure enough, well, let's write it down anyway, just for completeness sake. Let's get rid of these so that we can do that. We would end up with, no surprises, 1a to the 4 plus 4a squared, a cubed b plus 6a squared b squared plus 4ab cubed, and then b to the 4 at the end. And you can see I haven't bothered writing the ones there this time, but you can see where the numbers came from, Pascal's triangle. And again, the coefficient at the beginning there would this time be 4c0, 4c1, 4c2, and 4c3, and 4c4, as before. So that's quite nice, a nice straightforward way of thinking about how any binomial is expanded. Depending on the power, we look for that row in Pascal's triangle. Row 0, row 1, row 2, row 3, and so on. And we also know how the numbers in Pascal's triangle are derived using that combinations methodology that we looked at in an earlier video. So if I wanted to just write down a general expression then, so a plus b to the n, well, that's going to expand as, well, it's going to be n, c0 will be the first term, and then a to the power of n, in the same way as it was 4c0, a to the power of 4. And then the next term will still be n, but nc1 this time, and the power of n is decreased by 1, and b emerges there. And then the next term would be n c2, a to the n minus 2, and then b squared, and so on and so forth. A general expression then would be n c r, and a would be raised to the power of n minus r, and b would be to the power of r. And then this would carry on until we got to the end, and we ended up with ncn b to the n. Now, of course, there are some bits in here that we don't really need to worry about too much, because nc0 and ncn will always be 1, and nc1 will always be n. So we can simplify that formula if we like. In the formula book, the good news is it's all written there for you. There's the binomial theorem in the formula booklet, so you don't actually need to remember this, but you can see it's all there exactly as we just showed it. There, a plus b to the n is a to the n plus nc1, a to the n minus 1b, plus, and so on and so forth. So you don't need to remember it, you've just got to become very good at using it. And also, if you haven't got your calculator, just a reminder of what we did in one of the earlier videos, there's our formula for NCR. So if I needed to find 5C3, for example, then the maths behind that is n factorial, 5 factorial, over r factorial times n minus r factorial, which is 2 factorial. There's the maths behind that particular part of the expression. So there's just a very simple introduction, not very complicated. In the next video, we'll actually do some questions. We'll actually expand some things out, and we'll begin to explore where there might be things that are a little bit tricky, or that we might need to make some adjustments to what we were doing. But I hope that was a useful introduction. Thank you for watching. Don't forget to like this video and subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here. And drop me an email at ibmathsintense@gmail.com if you've got any questions, any requests, or if you spot any errors or mistakes in what I've been doing. But for now, enjoy your maths and take care.